So the next unit we're going to study is we are going to study Chapter 5, Topic 5. If we look at Chapter 5 really deals with rational exponents and what we call radical functions. Square roots, cubed roots, fourth roots. That's what these are. Okay, so the words are big, but a little different than last time, when we were working with rational equations and that kind of thing. So we're going to work with radicals in Chapter 5. So the first section of Chapter 5 is really going to deal with really kind of 3 or 4 things. The section's title is Nth Roots, Radicals, and Rational Exponents. So we're really going to work on 3 or 4 things. We're going to use the properties of exponents to rewrite expressions involving radical terms and rational exponents. We're going to find all real nth roots of a number. We're going to evaluate expressions with rational exponents, and then we're going to use those to solve equations by rewriting those equations and working with those different properties. So what does all of this mean, really? So essentially then what we're going to do really within this chapter is we're just going to look at really finding roots. So let's say that I have something like the equation x cubed equals 125 or something like that. But you've learned in the past, how to solve this. This is something that you've worked on before, and you said, okay, if we're going to solve this equation, we're going to say that this really is equivalent. We're going to take the cubed root of both of these sides. So x then is going to equal the cubed root of 125. Okay, and then we can find out, okay, what number multiplied by itself 3 times is going to give us 125. And one of the ways that we did this prior to it is we said that this was 25 times 5, and 25 was 5 times 5. And now since we're doing the cubed roots, we're looking for 3 terms as our group. So then the cubed root of 125 then was just going to be 5. And that's the cubed root. Now there are a couple things that terminology-wise we want to take care of. So in general terms, I had x to the third equals 125, but let's just put let's say that we've got x to the n is equal to c. So x to the nth power is equal to c. There's certain parts of this that we want you to take care of and do this. So this essentially says that you're taking the nth root of something and that you're taking the nth root of c. So if we were going to rewrite this would be x is equal to the nth root of c. And there's just a different way that we could certainly talk about this. Now this c right here, this is called the radicand. That's the radicand part of it. This part of it is the root. You're taking this root of it, or the index. You could also call it that, I guess. It's got a couple different names. But essentially what you're trying to find is you're trying to find that nth root of that radicand. So how many times when multiplied together does it take to get that solution? So we say the third root, or the cubed root of 125 is 5. If we look at another example, we could say, okay, let's solve x to the fourth is equal to 16. And well, my radicand is 16, and if I want to go ahead and solve this, there are a couple different ways you could solve this. You could subtract 16 and you could factor this to figure out what your solutions are going to be. You could certainly do that. Or you could just say, all right, in order for us to solve this, I'm going to go ahead and take the fourth root of x to the fourth, and then I have to do that to the other side as well. So then that's going to leave us with x is equal to And then we're going to break 16 down. It's 4 times 4, 2 times 2 times 2 times 2. But now we're looking for groupings of 4 because that's my index. I'm taking the fourth to the fourth power. So the solution to this is going to be x is equal to 2. Now you got to think about it as you're going to an even, and it's going to be positive. So positive times a positive is a times a positive times a positive is a positive, but a negative times a negative times a negative times a negative is also going to give me a positive number. So the solution actually to this is going to be positive or negative 2 when you're simplifying these types of things. Okay, so let's look at another one, or another way that we could possibly maybe even write it. So in this next one, I want to find the fourth root of 81. So that essentially means I want to find the fourth root of 81. So we break 81 down. It's 9 times 9, 3 times 3 times 3 times 3. So your answer is going to be 3. But again, because positives and negatives and such, if we were trying to find the value of x, then it would be plus or negative 3. If we're just looking at the fourth root of 81, you could probably just get away with putting 3. But if you have x to the fourth equals 81, then you need to make sure you put that positive or negative 3. So that's finding exponents. And what we said, if we look back in that previous example, if we have x to the n is equal to c. Another way that we could interpret this, and I did this earlier, is we could say that that's the same thing as x is equal to the nth root of c. But actually, there's another way to write this as well. Another way that this is written or denoted, this could also be denoted that x is equal to c to the 1 over n. Okay, all three of these things right here, here, and here are equivalent to each other. So if I have, for example, let's say that I want to find x, let's say x is equal to c, or let's see, not say c, let's give it a number. Let's say 144 to the 1/2. So I want to find 144 to the 1/2 power. Well, 144 to the 1/2 power is the same thing as the square root of 144. These two things are equivalent to each other. If you notice, my denominator is my root. My c value, my radicand, goes underneath my radical symbol. So that would be the same thing as the square root of 144, which then is just going to be 12. Okay. Another example would be, say that we have 16 to the 1/4. I could rewrite that as the fourth root of 16, which we've already said the fourth root of 16 is just 2. Okay. 25 to the 1/2 power. 25 to the 1/2 power is the same thing as the square root of 25, which then in this case is 5. Okay. So you gotta kind of keep this property kind of intact with how we're doing things. Well, now let's say that we want to find 25 to the 3 halves. Uh-oh. So 25 to the 3 halves, that 2's got to go out front. Because if we look at what we did up top, that 2 is our root. So it's going to remain our root. So this is going to become the square root of 25 cubed. The 2 is going to the radicand. The numerator is just going to stay with the 25. Okay, so another way that we could possibly look at this is another way that this can be written. It's 25 cubed. It's the same thing. Those things really mean the same thing. So you take the square root of 25, square root of 25 is 5, 5 cubed is 125. And that's what you would get if you cubed 25 and then took the square root of it. So if I go 25 times 25 times 25, I get 15,000. Oops. Square root of 25 is 5. 5 times 5 is 125. So both of these give me 125. Sorry, all of a sudden coughing. And so even with, fractions, we can kind of interpret this. So not necessarily want you to solve this one, but let's just think about what would 32 to the 3/5 look like if I was going to write it as a radical? Well, it would be the 5th root of 32 to the 3rd power, which would be the same thing as the 5th root of 32 to the 3rd power. Now, if you could figure out what the 5th root of 32 was, then you could just take that to the 3rd power. Right? But it's kind of you manipulating these and being able to reinterpret them, which we're going to find out something that we want to be able to do here rather quickly. We not only want to be able to go this direction of it, we want to go the other direction kind of as well. So let's just look at another one. And we could evaluate that if you want to, but I'm not overly worried about evaluating that right now. Just being able to rewrite it is kind of the big thing right now. But what if I have 27 to the negative 2/3? What is that going to look like rewritten? Well, the 3 is my root. 27 goes there. And you could put, and it's almost easier to do it like this, to the negative 2nd. If we could solve this a little bit more, the cubed root of 27 is 3. So we've got 3 to the negative 2nd. Remember, we don't like negative exponents. What do we do when we get negative exponents? We move them to the denominator. So this, in fact, is actually just equal to 1/9. Okay. What about 50 to the 3/4? Let's just rewrite it first. So it's the 4th root of 50 cubed. It's nothing that's going to work out real nice. So if you're asked to evaluate it, how do you evaluate it? You get this thing out. Something like this you're going to evaluate. How do you do this on your calculator? Well, really what you're going to do on your calculator is you don't even need to do the 4th root of 50 cubed. You can literally punch in 50 on your calculator, hit the 2nd button and the caret. Where's the thing? Hit that thing right there. So you've got backwards 50, don't hit 2nd, just hit the caret. So you got 50 caret, and then inside of the parentheses, put 3 divided by 4, close your parentheses, and you get this is equal to approximately 18.8. And you could really do that for all of them. If I wanted to do 32 to the 3/5, 32, you don't hit the second, you just hit caret. 32 second, then inside parentheses, I get it, it's backwards. You're gonna hit 3 divided by 5, close the parentheses, and you get 8. Okay, we didn't talk about what that answer was, but you get 8. We did that 27 to the 2/3, so 27 caret, parentheses, negative 2/3. And you get 0.1111, which is 1 divided by 9. So you can do these on your calculator too. But we do need to kind of be able to, key thing here is we need to be able to take these, and we do need to be able to rewrite them. But not only do we have to be able to go that direction, we really need to be able to go the other direction as well. So let's say that we have the 6th root of x to the 5th power. And now I want to write this as x to the what power? Well, the 6 goes in the denominator. The 5 goes in my numerator. So these two things are equivalent to each other. And when we start multiplying these things, which we're going to do eventually, trying to take the 6th root of x to the 5th times the 5th root of x to the 4th, not something you really want to do. But if we can rewrite them as exponents, it does make life really a whole lot easier for us. Okay, so let's look at another one of those. Let's go with 32. Let's go the 3rd root of 32 squared. And I don't want you to solve it, I just want you to rewrite it. So if we rewrite this, it's 32. My denominator is my root. My numerator is the other one. Those two things are equivalent to each other. Okay? Now, why are we going to use this, or how are we going to use this? Well, we're going to use this to help us simplify nth roots. So for example, let's say that we want to simplify the cubed root of 27m to the 15th. Okay. What does all of this mean? Well, it means that I want to take the cubed root of 27, and I also want to take the cubed root of m to the 15th. I want to do both pieces. Well, the cubed root of 27 is 3. So that's just 3. The cubed root of m to the 15th. Remember how you could rewrite this? You could rewrite this as m to the 15 thirds. Our root is our denominator. Whatever's there is our numerator. Just, again, just a different way to write this. I can simplify that. 3m to the 5th. And that's your solution. And you're done. Okay. Let's look at another one kind of like that. Let's go the 4th root of x to the 20th y to the 8th. Okay, so if I was going to rewrite this, this would be x to the 20 divided by 4 and y to the 8th divided by 4. Just a different way to write them. So this would be x to the 5th, y to the 2nd. And we're done. Nothing left to do with this. Now, you could always say that we do need to put absolute values around it. Sometimes because this is an odd, you'll see an absolute value here. I'm not overly worried about that. If you just had x to the fifth, y to the second, I would be completely okay with that. You don't need to take it any further than that. Let's take a look at another one. Let's look at the fourth, oops, I gotta get a pen here. Let's go with the fourth root of 256, x to the 12th, y to the 24th. Okay, so we're just gonna rewrite it. So this is gonna be the fourth root of 256, which is just going to be a number, then the fourth root of x to the 12th, and the fourth root of y to the 24th. Fourth root of 256 on your calculator, hit 4, because that's your root, and then hit second and that caret symbol, and you'll see something, it'll say 4x, you'll see something that looks like that, and then underneath it put 256. So that's 4. This is x to the 12 divided by 4, y to the 24 divided by 4. So 4, x to the third, y to the sixth is your solution for that one. And you're done. Okay. One more of those, and we'll go on. Let's go the cubed root of -8, a to the third, b to the ninth. Okay, so we've got the cubed root of -8. So what number times itself 3 times is -8? Well, -2. And I'm just going to go a to the 3/3 instead of writing it out all the time, and b to the 9/3. So that's ab cubed. And that's your solution. And that's simplifying these expressions. It's kind of the second part of today. The last thing then we need to look at then is we need to look at solving equations involving roots. So something like 2x to the fifth is equal to 64. So solving equations, and you've done this before. So when you're solving equations, first thing you need to do is make sure that you isolate your radical. So we're going to divide by 2. So you get x to the fifth equals 32. And then we're going to take the fifth root of both sides. And whatever that is, I think you get x is equal to 2. So your solution to this is going to be 2. Okay. And it has to be 2. It can't be -2. Okay. It is 2. So let's go with 5x cubed equals 320. It's a nice 5, by the way. Divide by 5 first. 64. Cubed root of 64 is 4. There's your solution. And you're done. So really, those are the pieces that we have for section 1. Things we need to be able to do. We need to be able to solve them. We need to be able to simplify them. And we need to be comfortable writing them from one mode to the next, whether it's in as a power or if it's in a radical type of situation. and you're going to need to be able to do those different types of things today. You'll have a book assignment today. Your book assignment is going to be on page 245. You can find it inside of, I'll try to put the PDF up in there. If not, go to the online text. You're going to do page 245, and you are going to do questions 25 through 42, as well as questions 48 and 49. So that is your assignment for Tuesday. Have a good day, everybody. Stay safe.